Okay, so here is what I got. Oh, you can't see that, huh? Come on, guys, come on. All right. Here is what I got. All of these are real numbers. Even 3 pi is considered a graphable number because on a number line, I could find where it goes. So we're actually going to learn about ungraphable numbers next. All right? So even 3 pi is considered a graphable number. Notice that on 14, it's R and Q. It's a Q because the decimal ended, right? It's a Q because the decimal ended. Okay? Check your answers and then let me know if you have any questions before we go to the second half of the lesson. Is there any questions?
I don't think so.
So far, so good? Okay, so now we're going to learn about ungraphable numbers. What? Okay, so we have another type of number called imaginary numbers. Okay? Imaginary numbers. Now, funny story is that the person who named them was because he did a bunch of work. His name was Rene Descartes. And he did a bunch of work with real numbers. And then some other dude realized these imaginary numbers also existed. But Rene Descartes named them imaginary and his real so that people wouldn't think imaginary ones were important. So that's how they got their name, like he was being sassy, right? So just so you know, when they're imaginary, they don't exist. They do exist. It's just that some old math dude in the 1700s was just being sassy. Yeah, super salty. Okay, imaginary numbers are ungraphable. Negative square roots or negative roots. Okay. And complex numbers is all numbers. All numbers. Okay, so let's talk about what I mean by ungraphable square roots, my friends. So when you guys told me what a square root was here, you said it's the same number times itself twice to get to that number, right? Yeah. Well, the problem with that is that if I have a negative square root, let's say I have negative 100, if I need it to be the same exact number twice, what happens if I have 10 times 10? Is it positive or negative 100? Positive. But what if I have negative 10 times negative 10? It's still positive. So the problem with trying to have a negative under a square root is that the only way for that to happen is for the numbers to be different. But then it's not a square root, right? So that is where our new friend I comes in. All right? I is equal to the square root of negative 1. I is equal to the square root of negative 1. So let's say I was going to do the square root of negative 100. What I'm going to do is I'm going to split that into 2 pieces. Okay? The square root of 100 times the square root of negative 1. So what's the square root of 100? What is it? Square root of 100? 10. And then the square root of negative 1 is I. So the square root of negative 100 is called 10i. It's a new type of number. Okay, let's do one more example. What if I had the square root of negative 4? So I'm going to split that into the square root of 4 times the square root of negative 1. So 2i. How are we doing, okay? questions so far? Okay. Look back at your examples above 6 through 15. Were any of those negative square roots? Flip the page back over. Should we add I next to any of those? Were any of those negative square roots? No. But what about complex numbers is all numbers, real or imaginary. So yeah, we need to add a C to all of those 6 through 15. Because all numbers are complex numbers. Yeah. Just make sure you fill out the log. Go over the exit log. Okay, I squared. Okay? I squared is the same thing as I times I, right? So square root of -1 times the square root of -1. See how on these ones over here, I could take the -100 and split it? I'm going to do the opposite with this and put them together. What is -1 times -1? +1. And what's the square root of 1? 1. I squared is equal to 1. And we already talked about this. None of them are imaginary. All of them are complex. We're doing okay? We're almost done. Okay, circle the real part of the number. And so this is a complex number. I have to keep it in two pieces because I can't combine those. One's real, one's imaginary. But it's one number. So circle the real part of the number. And so which is the real part of the number? The 3 or the -3i? The 3, and then it says to square the imaginary part. Good. Now, is this one considered real or imaginary in the end? It's called imaginary because I couldn't graph it. Okay? So this one's classifications would be I and C. Okay, 5, does it have an imaginary part of the number? So it would be C, because it's complex. All numbers are complex. Real, integer, whole, oh, I forgot, rational, and natural. Okay, this one is only imaginary, so that's I and C. And on 24, that's the imaginary part, that's the real part, but in general, because there's an imaginary part, it's ungraphable, so it's I and C again. Good? Okay, I want to know here, for 25, is that real or imaginary? Real. And it's complex, but what else is it? No, because it's not a whole number, right? Square root of 3 is not a nice number. What's its other classification? It has one more. Nope.
Q.
Nope, not Q. Come on. It's not a whole number. I know it's not those ones. Square root of 3. That's not a nice number, right? What is it? P, irrational. Good. 26, what would that one be? Imaginary and also complex. 27, what about that one? IC. And 23 is going to be the same as 25. Is there any questions on that? Okay, I want you to take a second with your neighbors and try 29 and 30. I want you to try and write those. These are the simplified versions. So try and figure out what those would be if they were still under their square root. Okay? Yeah. Because I know they had a negative under their square root, so I know if I did simplify it, it would have been imaginary. Because anytime I have a negative under a square root, then it's imaginary. Victoria. Okay. Okay. 3i. If it was under the square root, then I know it'd have to be negative because of the I, right?
Yes.
But then be careful with the 3 because that's also under the square root. So what was square rooted to get the 3? 9. Good. Square root of negative 9. Okay. What about 30? Anybody think they know 30? Negative 25.
Oh, yeah.
25. Good guess, though. Hey, I had somebody who asked me a question about 26 and 27, so let me just go back to that. I didn't simplify these, right? If I did, I could have changed this to square root of 6 times square root of negative 1 or square root of 6i. That's how we got that it was imaginary. So this 27 simplifies to square root of 11i. And that's how we knew it was imaginary. Good? Okay, we're almost done. Okay, impedance. Okay, this is one of the, this is just an example of when these imaginary numbers are used in real life. Okay, impedance is the measure of an object's resistance to an electric current or its opposition to the flow of a current. Complex numbers are used to represent the impedance of an element in a circuit. The voltage V, and this is a lot of words, but it's going to be really easy, okay? The voltage V is the real part of the complex number, and the current I is the coefficient of the imaginary part. So the impedance is equal to V plus capital I. Okay, where I is in milliamperes. I don't know if I said that right. A certain element has a voltage of 18 and a current of 2 milliamperes. So what's its complex number? So 18 volts and a current of 2 milliamperes. So I need to write it in this form. It's easy. Don't overthink it. Anybody have any guesses? Come on, Dakota. What? Just 2i? Yes, 18 plus 2i. The 18 is the volts, and the 2 is the current. And remember, we learned last unit what a coefficient is. That's the number in front of that variable, and our variable was I. Okay? Take a second and write the complex number that represents the two things on 32, and then we're done. I need 2 volunteers for the board, and then we're done. Who can do A? Who can do A? Gavin, you've answered a lot today. Let's see if I can get someone new. A? You guys wanted homework time. This is our last part today. 29A, or 32A, I mean. Bueller. Just pick one. Okay, number 2 can do 32A. All right, and how about 32B?
Mandy will do it.
Okay. Go team, go.
I got a shirt.
That's okay, just borrow one of mine and put it in the blue bin.
Mandy, I have one. Oh, touch it.
Don't touch it.
I probably did too.
I don't like doing stuff with the board. So they put 34 plus 3i, and then 13 plus 24. Looks good. Okay, anybody have any questions? All right, that's it for today. He hasn't been gone that long.